this point on, it's being recorded. Link to the recording later if you want to get back and revisit some of this. So if I miss anything, let me know. Send me a question on the chat. Otherwise, I am very gladly going to turn this over to Field Application Engineer Extraordinaire, Ron Jorgensen. Take it away, Ron.
Hey, how's it going, guys? Hey, actually, I noticed that there was one person that wasn't muted, and it won't let me mute. Can you help with that as I keep going forward? But yeah, hello, everyone. My name is Ron Jorgensen. As always, I'll try to live up to the hype that Carter builds for me, but we'll see. So I'd like to start with going over and just looking at a factory floor and looking at solve good problems. So I'm going to come back to this slide a few times, but just as a nice little overview, we have safety light curtains for protecting operators and keeping them away from hazards. The safety controllers are the
muted. Muted.
Yeah, the safety controller for taking in these safety inputs and changing the outputs to enable different safety devices or cutting off power depending on how your plant is used. But yeah, in general, the safety controllers are taking in inputs, they're doing some sort of process to it, and then they're changing an output. And we'll actually be doing a hands-on safety controller demo towards the in the upper right-hand corner, we have the mute kits for the light curtains. So sometimes you want to be able to pass product from a hazardous area out or vice versa. And the light and the muting is how we're able to do that. So this gives us the correct photo eye spacing. I'll give an example again on how to actually set up a mute inside the Banner safety controllers. We have e-stops, which I'll get into details with, and safety switches, but one thing I'd kind of like to point out is the lighting and indication. And I feel like this kind of gets left behind as far as the full safety solution goes, but making your operators and maintenance technicians or just people on your factory floor aware while using lights, it really does give that extra level of safety for letting whoever's around know what's going on. And if you're on a factory floor, universally what I've noticed is that red means stop, and yellow means caution, and green means it's safe. So using those to indicate what's going on in your facility, again, just kind of helps round out the full safety solution. With that, we'll get into how we do control safety. So we have 3 different levels. Starting with the simplest, which is just safety relays. You bring some safety inputs into the relay. We have 2 different kinds of resets, one that's automatic reset and one that requires a separate input. But this is a simple device for controlling some outputs in a safe way. One step above that is the SC10. It's our hybrid safety controller. So our outputs are relay contact output, which is great for bringing in signals and having to bring in those signals, as well as being able to cut some power to your machine if you have an older machine. The SC10 has really impressed me point for what you get. So the list cost of the SC10 is only $450, and when you compare that to a safety relay, if you have a case for 2 safety relays, from a cost perspective, an SC10 fits in well. There is a limitation to the number of inputs you can have, which I'll actually be able to show you guys how we can expand those inputs and get the most out of them using the ISD, and the SC10 is our flagship controller for bringing ISD to the market. So I'll be going over that a little bit later in the presentation. I'll have at the end there when I'm able to show it in the software and show all the different data that we can get through the ISD. I'll show it there. And then lastly, we have our expandable safety controller. So with medium to large projects, we're talking about replacing multiple hard contact relays. We can do up to 154 inputs, and I don't know the significant amount of outputs as well. It starts off as a main module, and then you can add on slices that communicate in the backplane. And it's a great way to, if you have a flexible system or you wanted to work with a single type of safety controller, it's expandable to allow for many different sizes of projects. And if I share my camera at the same time, what I'll actually do is I will set it up. This is just my desk at home here. And so this is the SC10, this whole thing. And so these are our outputs. So we're able to provide power. We actually have 3 sets of relay contacts that we can get here. Typically 2 is for the safety, and then 1 is for the status back to your PLC if you aren't using the industrial Ethernet diagnostic. So out of here, we can do Modbus TCP, Ethernet IP, and Profinet. We can send all the statuses from the controller to a PLC or a SCADA device, whatever you're communicating to. This right here is the programming port, as well as it takes a little memory dongle that I can show here on the next slide. But this memory dongle allows you to save the program to this little guy here. And if you have a blank unit, when you plug that in, it will pull in the program. So it's just like an EEPROM. So it's going to download the safety program. So it's a not hands up or reprogram or do anything like that. You take a blank one out of the box, you plug it in, you power it up, and then the program that you have saved to it will automatically download and start running in the controller. So just being able to cut down on installation time or swap out time and complexity, getting all of those benefits for getting your machine up and running. This little guy here is the way to do it. So then I'm going to get into some door safety. So we have a number of different ways that we can protect a door. These RFID non-contact switches. So these, in my opinion, are kind of starting to replace the magnetic switches. They're more robust and they allow for a larger tolerance than was allowed or available in a magnetic switch. They also are part of the ISD, which I keep alluding to it, and it'll be for the great, amazing payoff at the end when we really get into the details. But these are the switches that are using the ISD to take advantage of the diagnostic data. We also have hinge switches, which these are great for if you don't have a lot of room. If we can't fit in an RFID switch, replacing the hinges with a safety hinge itself. So you can install 2 of these and you can get your category 3, category 4 safety. And then if I switch back to my camera here, let's see, there we go. So these are the RFID switches. I have 2 sets here. I have one of them indicated with a U, and this is uniquely coded. That's what that stands for. And this receiver will only take this target. So in order to have a good signal out, the U's have to match up, whereas this one will take any receiver. So if I swap these, I think you guys can hear the click. So when I pull it off, you can hear it click. But if I put the U over here, this one will go green, but over here, it will not. You can see that it's actually blinking the error. It's telling me, hey, this isn't the right code. I need to see the one with the U on it. So if I switch these back, we can get them to click in. The hinge switch, I have one right here. It's pretty simple. Just a hinge mounted on the door, and we can keep track on whether it's open or closed. This one doesn't do anything. It's just cut off, but being able to work. And then lastly, for the 2 that I still see that are pretty common are the mechanical switches and the locking switches. With the mechanical switches, you have a key and a keyway, and when the key goes into the keyway, then our safety signals come on, and when you pull the key out, the safety signals turn off. One mistake that I see customers do when implementing this style of safety is when you're trying to achieve that category 3, category 4, these higher levels of safety, you have to take into account the mechanical failure mode. So mechanical switches actually have a mechanical failure mode where they have a single point of failure. So if this key breaks off in the keyway, I have an unsafe system. It's not fail-safe. And the door would be able to open with that key broken. It would be able to be open and our safety contacts would not trigger. So with mechanical switches, you're actually required to have 2 mechanical switches on the door in order to get that higher category level of safety. Whereas with RFID and magnetic switches, you can have a single device with 2 electrical outputs, 2 OSSDs or 2 safety signals. You can do that with an RFID because there is no mechanical failure mode with RFID or magnetic switches. If that target falls away or falls to the ground or it's not sending its signals, then it's going to trip, and that makes it safe. But with mechanical switches, that's one thing that I see in the field more often than I like is just having a single contact. It's dual contact in here, keeping in mind that mechanical failure mode of the single key in the keyway. Keeping that in mind is important when designing your safety system. And then finally, we also have locking switches. So these locking switches are used for keeping operators or technicians or anyone away from your machine while there's still a hazard. So even if I hit an e-stop, there are some machines that have a lot of potential energy. Think of a large spinning saw or a press with a lot of momentum behind it. When I hit a button, you want that hazard to go away before we allow the door to open. So locking the door, keeping it locked while that hazard goes away can be very important on some projects. So yeah, we use locking switches for that. It's a little solenoid, we provide 24 volts, keep the door locked. Hazard goes away after a certain amount of time, we unlock the door. So in our factory floor, you can think of these different access doors. You could put RFID, you could put your safety switch in here, or maybe a locking safety switch, depending on what your safety system says or how long the hazard exists past the safety trip. That's really what decides on whether you need a locking switch or not. And that brings us to light curtains. So light curtains are another way to keep people away from hazards. And what they do is they transmit and receive a little electrical beam that goes between them. And we have a wide variety. And typically the biggest distinguishers in a light curtain are what size are they, what's their resolution, and how heavy duty are they. Those are the 3 main things that I've noticed that we come into contact with when using light curtains. And we have a wide variety, including ones that will accept the muting kit. So that muting kit, again, I'll go over it in the program, but basically you trigger a sequence where one photo eye has to break, the next one has to break, and then the light curtain breaks. And as long as it happens in the right sequence, we say that it's okay for the light curtain to be blocked if a muting sequence is occurring. So that allows product to pass through, but if someone's a pretty neat way to allow your process to continue without becoming unsafe. Another accessory that I like with the light curtains are these little indicators on top of the light curtain. So when you're up close to the light curtain, it's actually easy to tell if it's blocked or not, not just because you could see something in the way of it, but there's indicators along the length of the light curtain that show you where it's blocked. But from across the factory floor or from any kind of distance away, you really would rather use an indicator that shows whether the light curtains are broken or not. So these actually integrate right into the top of light. For installation, the last accessory that I'll talk about for light curtains is the laser alignment tool. So the alignment of the light curtains, although they can be forgiving, it is important to make sure that they're aligned properly so that the way they work well. And this little tool mounts onto the top of them and shoots a laser across and just helps with. And then in here, back to this fun slide, you can see that we have, the higher resolution to guard the person away from the area that's being worked on. And we have a lower resolution where there shouldn't be any kind of human interaction. We can use a lesser resolution light curtain, but we still, as these products pass through, we don't want to trip it. So you can see the muting kit on here that's allowing the engine there to pass through. And that brings us into e-stops. We have a number of different kinds of e-stops. The two that I like the most, we have the mounted e-stop and the flush. What I like about them the most is they have these little M12s at the bottom, so we're not wiring any kind of hard contacts. It's more of a plug-and-play style of safety. It's really neat about these is you can get them with indications, so that way, and they have programming built into them. So that way, when the e-stop is pulled, it's green. If any e-stops in the chain are pressed, all of them go red, and then the one that is pressed will blink red. So it'll flash red. So I can actually show you that on my camera here. So I'm going to switch back over to the camera, and you can see it actually, how bright the e-stops are doesn't play too well with my camera. And that's what's the important part. There we go. So you can see my e-stop here. It's just a normal twist release, but when I press the button, this one's blinking red. If I had other ones in the chain, then they would all go red. When I pull the e-stop, we can see that it's not activated, so it goes green, and I can hit my button to reset it. And that button reset happens in the safety controller, not the e-stop. So the e-stop still works as a normal sensor. It's just that they'll send signals to the other e-stops in the line when it's red, and when it's pressed, it will blink. Share my screen back. Cool. All right, and then as far as e-stops go, we also have the panel mount e-stop. So these are, pretty straightforward. They mount in a panel. They have contacts open on the back. We have some with the lockout tagout built into it. So when you press the e-stop, this little channel actually opens up, and you can do your lockout tagout directly on the stop, which stops anybody from pulling the e-stop. So it will keep your system safe while you work on it. And then we have the pull cord e-stop. It has an e-stop built in, but this is for using long runs. When you need to protect a very long area, you can mount a cable that starts here and ends up to 100 meters away. And at any length along that cable, if somebody pulls it, then it's like hitting the e-stop. So you're able to cover a large distance in safety with a single device. These are actually pretty neat because they have, it's the same thing where the off on off, where it has to be held in a middle position. So if I cut the cable and all the tension goes away, that will trigger an e-stop the same way as if I pull the cable. So these are great for fail-safe areas where you want to cover a long run. And then finally, I put these in with the e-stops, but they're the safety enable. So these are just, they're commonly what they call the dead man switch, and what they have is you have to hold them down halfway for them to be on. So if I squeeze it too tight, it'll go off. If it's released, it'll stay off. But if it's held in the middle position, then it will stay on. I've seen this used a lot for jogging situations or temporary bypasses. If you need to do that, safely, this is one way that we can do the safety enable. And then back to this fun slide again, but you can see that we have the e-stops kind of placed around this robot cell. So this is where, e-stops are kind of used. But one thing I'd like to point out is on this conveyor run, if I had this and if this extended a lot longer, I could put that cable stop at the end here, run the cable all the way along, and then I'm able to protect, anywhere along that whole line. So that brings us into the two-hand control. So this is a two-hand control station. There's actually two little buttons on the underside of this station, and it's used for when you need to know where your operator's hands are when you're going to start a process. I see this most commonly in like press brakes or punching systems. Anytime there's a collaborative or semi-collaborative area when you're working with a large machine or robot, and you want to know where their hands are safely, you can use this two-hand control. I'll talk about it when we get into the software, but it's actually pretty neat on how simplified it is to use in the safety controller versus what you have to do if you want to use relays or other like safety PLCs and things like that, because there's a lot of watchdog and debounce checks, and there's a lot of checks to make sure that both two-hand controls are working, and there's some pretty neat timing things that have to happen. But inside the safety controller, you'll see it's just a function block and you drag it. It's pretty neat. This is half of a two-hand control. I don't call it a one-hand control because typically we're going to use two of these, but this is what those buttons look on the inside. You have the shield over the top. You have the inductive button here, so operators can use it with gloves or anything like that. Put your finger on there, or two fingers on there, and you're hitting a button. Cool. So we're finally getting into the thing I've alluded to all the way up until this point, and it is the ISD. ISD stands for in-series diagnostic, and what it is it's built into each safety sensor, and it allows us to create a safety chain where all of these devices are in series. What's unique about it is we're able to get diagnostic information from each sensor on that chain. So if I have these in the chain, just like I do, and I have two OSSDs going to my safety controller, just like it's shown here, if I open up this safety contact, this door switch here, if I release that contact, the safety signal will drop off, and then I will get a signal from this sensor saying which sensor is open. So this one will say, safety trip, position 1. So I know that this is the switch that is open or broken. So being able to get that kind of information over your safety wire, so we're not adding complexity to wiring, and we're not adding complexity. Actually, we're removing complexity by making it all M12. But having this additional information, and when I go online with the controller, I'll show you just how much information we can actually get with it. But it's really powerful for getting our systems into the industry 4.0 that everyone keeps talking about. So this is just one way we're able to do that. So the ISD we deliver value across the whole length of the system. So we're able to prevent the downtime because unlike the RFID switches, I can know the distance my target is away from my receiver. So being able to know that, so that's very common, like door sag or bolts come loose or something like that, that's holding the RFID. I can know that the distance is changing and call over a maintenance technician before the safety system actually trips and brings down the machine. That goes the same with voltage. I can know the voltage of each of the RFIDs, and I would be able to do preventative downtime. So I'm able to call someone over before there's a catastrophic error or an error that shuts down the machine. With the ISD, we can also reduce the downtime. So if the machine does go down, knowing which e-stop is activated or which door is open can be really helpful. I think that coupled with the flashing in the lights really brings down the chasing of the e-stops. I've talked to numerous customers that talk about, it took me 4 hours to find out which e-stop was pressed, and it was, it's all back in a corner or something like that. But having that information, displayed or available to the PLC, to show on an HMI or something like that, it can really help reduce that downtime. And then finally, just being able to reduce in cost and time on the front end. So now, traditionally when you have, let's say, a chain of e-stops or a chain of door switches, traditionally what you do is you bring your safety signals back, and then you have to bring a discrete wire from every single sensor back to an input card on the PLC. So that way you know which door is open and which e-stop is pressed. Well, you don't have to do that anymore. You can get that information from the ISD which is translated by the safety controller, and then your safety controller is what's going to report that to your PLC instead. And then I'll show in the software again, but just how easy it is to set all of those configurations up in your safety controller. It's a great time saver. But cutting back on the wiring is not a thing to take lightly either, because everything's 4-pin, everything's connectorized. So versus stripping and then stripping again and then labeling and terminating, going through that whole process for how traditionally signals and safety stuff is set up, being able to just go to M12 connectors, plug everything in, and you're good to go is really powerful.
Hey, Ron?
Yes, sir.
Yeah, just a quick question here. Is any special cable required for that, or is it just like standard 4-pin unshielded M12?
You nail on the head.
For that?
Unshielded standard 4-pin M12. It's pretty neat. It's pretty amazing, and you can still, we're not limited by run. I think it's just the same distance as a normal sensor for your OSSD. So you get a pretty long run with it too.
Nice.
So with that, what I'm going to do is I'm going to open up the safety controller, and I'm going to put my demonstration where my mouth is and show you guys how to set up. What we'll do first is, I'm going to start a new one first. So this is the safety software. When I start a new one, it asks me which controller am I going to use. I'm going to use the SC10. Just going to say yes to a new project. But this is our programming platform, as I have a couple of different tabs across the top. I'm going to go a little fast through here, and if we want more of a deep dive or any kind of more information about how to program the controller, I'm available afterwards, and I'm here to help you guys, get through, my first safety project. But anyway, so here it's pretty simple. What we can do is we can use this little plus button, and we can add in different devices. Once I'm adding in these devices, I can select how I want to wire them up. For this, I'm going to add in a two-hand control, because I'll show you guys how that works. This is how many inputs a two-hand control. You have half of a two-hand control and the other half of a two-hand control. We'll get that in there. I'm going to add in a light curtain, and I'm going to add in a muting sensor pair. I'm going to do mine as PNP. So we have this here. And actually, I'm going to click this. So in my functional view is how I'm actually going to program it, but I don't want to do the e-stop one. So I'm going to bring these down here. I'm just dragging and dropping just for organization reasons. So I have my two-hand control input. If I click in these centers here, I can select my function block. And then for my function block, I'm going to select my two-hand control block. I'm just going to have a single two-hand control station. And then this is where it gets complicated. I'm going to take this little red square, and I'm going to drag it to the input of this two-hand control. And I'm going to take this little red square, and it's going to control this output. So I've programmed and wired my two-hand control for activating this output. Down here for my muting, I'm going to do this. It's not that difficult. I'm going to select this muting block, and we have a couple different muting configurations. So where I can line up my sensors. This is application specific. For demonstration purposes, I'm just going to do the X that allows direction of product in either direction. It can also be used for, like, again, those semi-collaborative and collaborative robots. You can use that for setting zones on if a robot's rotated or when it's allowed to rotate, where it exists. There's other ways to do this now, but this is still valid and used. So anyway, I have my muting block. I got my X pattern. I'm going to mute for 30 seconds. I'm going to hit OK. And then I'm going to take my light curtain, drag it to the input. I'm going to take my muting pair and drag it to the muting pair. I'm going to take this little red square and put it here. So now I have a light curtain that's allowed to be muted, controlling this output, and a two-hand control controlling this output. And if I go into my simulation mode and I hit my play button, I can control these outputs. So the two-hand control, if it's on, it's on, and if it's off, it's off. From the user standpoint, or the front end that we're kind of looking at here, there isn't a lot of complicated things happening with this two-hand control. And in simulation mode, it's pretty straightforward. But this block is actually doing checking of all 4 inputs and making sure that they come on within a certain amount of time, which gives us a good read, which allows to safely activate our output. But on my end, you know, dragging squares to squares is pretty easy programming. And then we also have our light curtain down here. So this light curtain controls this output. If I break the light curtain by clicking it and it goes off, then it goes off. But if I start my muting sequence, which I can click here, I get this little green bar, and then this starts to count down on how long I have to mute, and I configured that on the function block page. But now if I break my light curtain, my output will stay activated the whole time. If I match my cadence correctly to explaining it, we'll get this little green bar to go down, and then it will actually fault it out, even though it's getting broken, because I told it could only be muted for 30 seconds. So it's muted for 30 seconds, and it goes off. I make the light curtain, turn off the muting pair, and it goes on. But that's how simple it is to do muting and a light curtain controlling an output. It's a single function block. If I open up here, if I open this safety, what I'll do is I'll actually go online and I'll activate my camera to show you the live version of what I have here. So what I'm going to do is I'm just going to plug it in. Plug this in. I get a couple more options, and I can go to this live mode, which allows me to see in real time how my system's working. So if I break this chain, you can see as I break it, the safety happens immediately, and I'll show you where the ISD information is in a second. But I can break this, and then I also have my standard magnetic switch. Oops. There we go. And then I have my E-stop here. Press my E-stop, press my reset button, and that makes my outputs come on. As far as programming, when I had talked about the configuration to get our diagnostic data from the PLC, or from the safety controller to the PLC, this is where we do that. So I have a list here. I actually don't mind clearing them, because I know it's very simple. I just hit the auto configure button, and it will assign a data location for each of my inputs, outputs, and so my chains here. So I have all that information. What's nice about the Allen Bradley PLC and the Siemens PLC that we have for our controller is this nice little export button. So I can use this export button to create a CSV to import my comments. So it makes the integration more seamless. That also is true for my Profinet. I'm going to change my protocol over. If I do a clear all and an auto configure, you see that it assigns my slot addresses when I do my export. I give it the controller name, and I can import the XML file directly into my Siemens PLC, and then all of my data is going to be there for configuration. So with just a couple of clicks of the buttons, what used to take me longer than I care to admit, I'm now doing in 2 buttons, which, you know, past me can see me now. So if I go online with, I'm going to say don't save. So I'm going to read in from the controller. So this is one of my favorite parts of the demo, is being able to show the ISD data. So I'm just clicking on one of the devices in my ISD chain, and then I'm going to be able to look at all of my ISD information here. The one thing that I'd like to point out, as I'm going to show you, is we have this actuator distance that's less than 7 millimeters. But you can see that as I break it away, so the ISD will take just a second to update. There we go. And you can see that my OSSDs are still green. From a safety standpoint, there's nothing wrong, but I'm able to read that 9.8 millimeters, so I know that it's a little bit further away, maybe than I expected, and I'm able to get this information into the PLC out of the the port here, the RJ45 port, I can get that information out of to the PLC to help make the decision to, call someone over. And, that's the same thing that's true with the temperature and the voltage for that. I can actually get everything from, if you look at here at the expected code and received code, I can actually, I'll click on the high unique coded one, and you can see that the expected code and the received code match. But if I pull this away, it'll go away, and then I'll put this guy on. You can see that the received code will be wrong. So I have a fault, my chain is broken, but for this one, because I'm not expecting a code, I can actually get it to go green. It won't reset my safety because they work together, but as far as this RFID is concerned, there's really nothing wrong. But this guy here, he's saying, yeah, I detect a target, but it's not the right one, so I'm not activated. If I switch it back, we're able to do that. So these are, yes, sir?
Yeah, I was just going to point out, and that's a great demo there, the magnetic switches are still a very viable solution, but the downside of them over the years has been they don't have that much range, and doors can false trip because as it sags and gets out of it gets out of distance, and all of a sudden you got to figure out which door is actually not making properly, even though the door looks closed. As Ron's showing in the demo here, we can handle a lot more distance and forgiveness, but even monitoring that the distance of the target whenever the door is open and closed over time and it starts to sag, you can actually do some predictive maintenance and tighten up your door before you ever have to deal with the nuisance trip and therefore prevent downtime.
Yeah, so I just pulled those apart until the safety signal turned off, and you can see the additional distance we can gain with them. And
they're better with lateral movement as well, right? And misalignment with angles.
Yeah, for sure. Especially on the magnetic side. The magnetic ones can be a little finicky sometimes, and it's not that they don't have their solutions, but Carter's absolutely right with being able to get better lateral movement and additional distance. So they're a little bit more robust if what you're looking for is gaining a little distance.
Yeah, the question came up if the RFID switches are wash down rated, and these are IP69, so we do use them in food plants.
Awesome. Cool. So that's what I have for the safety controller demo. I'm going to jump back to here and talk a little bit about our safety scanner. And so our safety scanner, what we have is it shoots a beam out, and then it's able to read that back. I kind of equate these to like a diffuse light curtain, so it's like a single-sided light curtain. And we have a great front display on here. I'm actually going to like this. Almost. There we go. Oh, hello. Better? There we go. Yeah, so here's our front display, and you can see, so it's shooting a beam out, and we're able to read it. If I show you online with the software, what I really like, so this is our SX5 software. If I go to a new safety configuration, I go to scanner, discovery, it will actually find the scanner even if I'm not on the same subnet. It looks at it by the MAC ID. And so I found my scanner here. And if I'm not on the same subnet, it'll actually automatically change it for me so it's easy to connect. So on my camera, I'm pointing just to where the programming port is. So I just plug this standard Ethernet M12 into the front, and that goes into my computer to an RJ45, and then I'm able to find it here. So then once I'm in the software and I have it selected, I can just go forward. So I just navigate with these arrows. So it's actually downloading the information that I have on it. I have just generic information. I give it a name, who the author is, what kind of description we have. And then as we step forward, I can decide what the outputs do. So safety scanners have two different kinds of fields. They have a safety field and a warning field. A warning field is basically, it's just a warning to let operators or floor people, anyone on the floor, know that they're getting too close to a hazard. So having an output to designate, show on a light or something like that to warn them that there's a hazard before they trip the safety. That's where we configure it here. It also has different zone sets. So if we have different situations where we want different areas of coverage, you can actually change that through the safety function. So it'll actually change the area that the scanner is looking in. We have our input configuration. This is for, you can do like an automatic reset or a manual reset, which typically if you're using a safety controller, you can use automatic reset where we use the raw signals in our safety controller and we do the resetting in the controller. That's the most common. But if you need to use this as like a standalone or with some sort of safety relay or something like that, we're able to do that. We can do some resets in the scanner itself. In here, we can change the number of scans. Basically, it's helped to cut down on the nuisance trips. I feel like few people, I wouldn't say few people, but it is important to keep in mind the nuisance trips when looking at a safety system, because if there are a lot of nuisance trips, then your system actually becomes less safe. And changing the number of scans so that way we don't trip as much on dust or wood chips or little things that fly around a facility. Just being able to change that can be helpful. And then here is where I like is, so basically what we're able to do is on this section, we are just programming the area. So we're going to draw on the screen. If you're used to PowerPoint, then this will all make a lot of sense. Or PowerPoint, Paint, this will make a lot of sense to you. So I can do a teach-in button here, which what it's going to do, it's going to show all the different gray areas are areas that it sees. So it can see the camera and the different cables that are in the way right now. But once I'm on here, if I want to work on the safety, I can show the safety and the warning just by clicking these boxes. So if I'm working in the safety, what I can do is I can draw out very simply where I want to protect. And if I have a lot of different complex fields, I can actually draw them, completely around all the different areas that I want to. And that goes true for the warning field as well. So the warning field is the yellow. I'll leave that one for now. But so what I'll show you in the monitoring is we have our system here. So I have all these different lines that are breaking the beam. And so if like I move the cable and move some of this stuff, tilt the sensor, you can see my whole frame changes. But then as I pass my hand through, I can break the safety field. And you can watch it go around. And in the lower left-hand corner of my screen, it's showing whether the output is on for the warning or the OSSDs are on. Or off. So you can see that in my warning field is broken by all these different, whatever they are in here. And then when I put my hand close and I break that field, yeah, we're able to see. So setting this up by and here it's shown up front and center, so it's guarding this whole area, so we know when a person is approaching the robotic cell. Okay, so that is my presentation, and do we have any more questions? All right. Well, yeah, I'm available right now to, if anybody has any questions or would like additional training or anything like that, I'm happy and more than willing to talk with you guys about your factory and your safety applications.
Yeah, I was talking away there on mute. So
Oh,
sorry
okay,
about that, Ron.
makes sense. Okay.
Yeah, my phone was cutting out, so I had to go full pilot headset here. Now, thank you very, very much, Ron. That was fantastic. And if you have any questions, please do type them in. We are going to send out a follow-up email that will have the information talked about today. We're also going to have a survey. Would really, really like to have you fill out that survey. It'll take just a moment. We'd love to know what we're doing right, and would like to know what we can do better as well. We are going to stick around a little bit, so if you have any questions, feel free to put them in the chat box. If you want somebody to give you a call and talk about an application, then we can do that with your phone number, or also get with whomever invited you, whether that was one of our outstanding distributors or if it was an ABC regional manager. We'd love to get together and help on an application. We also, this Thursday coming up, we have a presentation on our vibration and temperature condition monitoring. So please go check that out and sign up if you'd like to join us with that on either Thursday morning or afternoon. But that is the formal portion of our presentation. We greatly appreciate everybody's time and sticking around with us, and we're going to stick around for a little bit. So if you need to go, cut on out. Have yourself a wonderful day, and thank you very, very much.
It looks like we do have a couple of questions. So I have, do any of these devices have hazardous location approvals?
Oh.
That is a good question. I don't know. That is something that I will definitely be able to.
Yeah, these, as far as like a class 1 div 2 or anything, no, these do not have any hazardous rating.
Okay.
On them.
And then they also asked, does Banner charge for their software? No, we don't charge anything for the software. I actually work with customers pretty often. They'll have the software as they're kind of looking into the Banner safety stuff. And honestly, a lot of times the safety controller software is what sells it, just because of how simple it ends up being. But, doing one-on-one trainings or group trainings or company trainings, whatever, for getting you knowledgeable on that is something that I like doing. So I would have to do it if I didn't like it, but the fact that I do like it helps. Does that make sense?
Yes. I got somebody just looking for some information on the looks like the scanners.
Mm-hmm.
So we'll make sure we send product link out as well.
Mm-hmm. Mm-hmm.
Yeah.
Can you hear me? Hello?
Yeah. We
Okay.
hear you.
Yeah. Okay. So I have a question about that safety controllers. Do you
Sure.
know what is the ambient temperature range?
Well, if Ron will talk for just a second, I can look it up there, Ron, if you want me to.
Yeah, I can.
10-2 ROE.
That's a good question. Where is it going to be going?
Everywhere in the world.
Now we're talking.
All right, let's see here. Maximum operating temperature for the SC10 is 55 degrees C. What is that, like 131 F? Is that what that is?
Yeah, that's okay. That's okay. What about the minus temperature?
I am looking for that.
Oh, I also got a question here while you're looking that up.
Sure.
So they asked, when doing SIL or PFD, I think PLD, system level approvals, there's a lot of calculations involved. Does any of the software assist with that to ensure compliance to the required standards or levels? Somewhat. So things that are going in and out of, or into the controller, it will assist in making sure that what you have, excuse me, sorry. Whew. Sorry about that.
All choked up.
Yeah, so
did the question move you?
It did. So it will help to make sure that what you have in the safety software is what's wired up, but you can configure the safety controller in an unsafe way if you purposefully do it, right? So it helps some, but the main safety person is going to be the guy programming it and the guy behind the computer.
And for the SC10, the low end temperature is 0 degrees C. So if it's going somewhere colder than that, we might want to put in something to heat it up.
Okay, thank you, sir. Appreciate it.
Yeah, thank you very, very much. Were you getting some questions to presenter only, Ron?
I was. Yep. I just
Okay.
keep it open afterwards.
No, that's great. I just didn't see. I just didn't see them. I want to make sure I didn't miss the questions. All right. Well, Ron, it was a really good job, sir.
Thank you very much. Just trying to be like my hero. I won't say who it is, but I just like to be.
I was going to say Kurt's not on this one.
No, it's
so.
Rodney Dangerfield. He's the guy.
Hey.
Yeah, I'm just being silly.
Got a kidney-shaped pool with a stone in it. Hey. Oh, there's something popping up. Oh, thank you. Okay. So we'll send a product link on the scanner. Yeah, I thought your audio was cutting out. Actually, it was mine. I had to join with the phone because it wouldn't. Computer wasn't keeping up.
A lot of juice.
Didn't want to miss a thing you said, man. Yeah, didn't want to miss a thing you said.
Oh.
We got a comment there. Excellent presentation. Thank you very much. Adalberto, I believe is how you say that, and I would have to agree wholeheartedly.
Man, I got to start doing bad on these things. So I set the expectations a little bit lower. See, now next time you guys will expect something even greater. I just it's a lot of pressure.
That's a good thing is if you start doing bad, you won't have to do that many of them, right? Yes, very good presentation. Really like the product line. Bobby Brignac. Thank you, Bobby, very, very much.
Oh, man. And that all this improv, it costs as much as the software, right? It's all free. Except the software.
It's not a direct question on here, but somebody's probably wondering if you're available for parties. So just as long as we call it a safety party or it supports one of the product lines we do, then I'm sure we can do something like that.
I can juggle. Magic tricks.
Conversations. Product lines. You
Yeah.
can juggle lots of things, can't you?
There you go. Just imagine my clown reviews. Really good, but wouldn't be quiet about Category 3 safety and how important it was in facilities.
He scared the kids about machinery.
Yeah.
At least we know how to make it safe. All right.
That's great.
All right. Well, it's probably safe to call it. And if you're still on here and we missed a question, go ahead and type it in. Otherwise, we will call this one a wrap and get back to other things. Well, Ron, again, very, very good job, sir. And look forward to the next one.
Me too.
All
Take
right.
it easy.
I'm going to stop the recording. Okay, now I'm going to stop it. I was just going to see if you said something stupid because I said I'm stopping the recording.